Whatever.
What? Haters on the internet? Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Tom Nardi, managing editor of Hackaday.
Today we'll be talking about vintage NASA soldering, mouse bites, ATTiny85 graphics, and PVC pontoons. This week in the news, we have some good news. It's spring outside, the flowers are blooming, and the nerdy festivals are starting to fire back up.
I'd finally, after being in hibernation for the last couple of years.
For sure.
The big ones, at least have gone on record and say, we're back. I mean, we're going to see a lot more slowly, peeking their heads out. But both the Midwest and the East Coast Rip Rap festivals are now locked in for normal, full-scale, in-person events, which is really cool. Midwest is happening in June, and then East Coast will be in the fall in October. Same places as they were before. As far as it looks right now, no weird hoops to jump through, no limitations on how many can be in. I know the Midwest Rep Festival, they did experiment with like a scaled down thing where only X amount of people could come in, and good on them for trying, but it's always really hard to control that kind of thing. I'm looking forward to it. I know personally I'll probably make it to the East Coast one. That's a lot closer to me. I went the last couple of years, and it's always been a good time, and I'm looking forward to seeing all that pent up 3D printing energy coming out in a big burst. I imagine that both events are going to be, one for the record books.
Off the hook. Yeah, Midwest Rep Rap Festival is the strangest thing ever. For the longest time, it was really, literally the epicenter of the kind of open source Rep Rap 3D printing community, and it's in Goshen, Indiana.
Yeah, right.
At a 4-H fairgrounds, right? It's the strangest thing. But all of the heavy hitters from literally all of the world would congregate there. And I think a few years back, we sent Joshua Vasquez there, and he wrote up some stuff. He was at the time kind of pushing his open source Jubilee 3D printer with Tool Changer project. And I know that he hooked up with a whole bunch of kind of industry people and E3D and stuff, and got some really good feedback on his project, but just kind of walked away overwhelmed by the feeling of how small a world it is, really.
This is a kind of interesting side note. We were all set up to come to, what was that? That would have been 2020, right? Yeah, we're all going to 2020, and we're supposed to have a table, and we're going to have little 3D printed things to give away, and COVID kind of changed those plans. So I will not say an exact number, but there are many, many little 3D printed Hackaday giveaways in a box that never got distributed. So
in Tom Nardi's basement.
Yeah, if we can get somebody to Midwest, I will make sure that they are there, and that'll be ultra limited edition.
Oh, fantastic!
It'll be from the Rep Rap Festival that never was.
They're well aged. They should all have a vintage date on them or something.
Oh yeah, I printed a date on them, so that was a lesson.
Did you really?
I learned that lesson the hard way.
Yeah, super.
If there's even the risk of a pandemic on the horizon, don't print a date on anything. That's the takeaway.
Man, crazy world. That's hilarious. Other news of festivals, summits, etc. Next week, Open Source Hardware Summit and Vintage Computer Festival East are both on April 22nd. So we'll have some more detail coming up in the next week on Hackaday. You won't be able to miss our articles on them, but I guess the podcast will go live exactly when Open Source Hardware Summit is running. So it'd be unfair to give you such short notice. Check it out. Keep your eyes open this week, or just head off to their websites. Links in the show notes.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to What's That Sound? This week is a sound challenge week, so I'm going to make some noise for you. You're going to try to guess what it is. head over to our website, hackaday.com/podcasts, fill in the form, enter your guess, the name you'd like to be called on the air, and if you get the answer right, we will draw your name at random, and the lucky winner gets a t-shirt. Are you ready for the sound?
I'm on the edge of my seat for the sound.
This is a special sound this week. This is going to be a live sound. I grabbed something out of my closet, and it sounds a little bit like this. Any guess?
Buttons. It sounds like you're pushing buttons.
More specific?
But more specific than that, no, I have nothing more specific than clicky mechanical buttons.
Super. Well, I'm looking for something a little bit more specific than that, so if you can figure it out from the sound, let me know. Make your best guess, enter it in the spreadsheet, and we will come back next week and see what happened. All right, you ready to start up some hacks?
Yeah.
Let's go. I'll go first this week because I always go first. We should switch that up too. What the heck? My first hack this week could have been a retro tech-tacular. This is an old how to solder movie on the YouTube channel Periscope Films. NASA hardware techniques, soldering space electronics like it's 1958. This is a fantastic old movie. It's got all of those 1950s, 1960s production quality. It's got the stern-voiced announcer, solder is not a glue. It sounds like it's a Simpsons parody of exactly what it is, almost.
Harry lacks experience, but he has a deep respect for any electrical joint.
But it's also full of fantastic tips about soldering up to NASA standards right before kind of the space race. And I think if you put this in that historical context, it's also really interesting. Like, this is kind of just post-war, so they have people who were doing electronics work for, like the Navy or the Air Force. I can't remember what he said in the video. And then they're like retraining them to work for NASA to do soldering for the space program as part of this kind of long push to get, to eventually win the space race or whatever that means. So it's kind of weird and fun from a historical perspective. But then again, from a just how to solder perspective, it's not a bad video. Like, you could do worse than to watch this, even if it were made today. I guess the thing that struck me most about it, I was looking through it with kind of an eye to see if they had any, super old schooly techniques that we don't do anymore. And the one that did hit me is at some point in time, the guy cleans off the copper traces on the circuit board with this old school eraser thing. It's a pencil. It's an eraser with the rubber shaped like it's the lead in a pencil, and it's got a funny little wire brush on the back. I don't know, they used to have these for typewriters or something back in the day. I mean, that's before me even. But he's cleaning the contacts with a pencil eraser. And this is the kind of thing you do with flux, right? Where you just want to get the oxides off of it. But, it kind of strikes me that may not be a bad way to do it. To actually physically clean the copper up a little bit before you hit it with the flux to get off the worst of the oxides. And why the hell don't we do that anymore?
Yeah, right. If it's good enough for NASA, it's good enough for our Arduinos.
Yeah. Yeah, right?
I'm glad, certainly not surprised, but I'm glad that you picked this one to talk about, because it was, as soon as I saw it hit the site, I think it's so fantastic. They, they always say they don't make them like that anymore. And this is a perfect example, like I said, that period of instructional video, it is post-war kind of stuff. It's great. It's great. It's the kind of thing you would have playing on a loop in a museum or something. It's a little time capsule, and I love the way they like you said, they portrayed it as this was, you kind of follow this guy through. He's getting hired, I guess, at NASA, because they make a point that they say they were getting he's an expert. He brought his own iron, and the dude stands up and he's got a soldering iron in a hip thing, like a pistol, like he's
In
in the
a
old west or
holster.
something. Yeah, right. Like he's gonna quick draw on somebody and see
I
who
want
can
one of
solder
those.
faster. But that's the thing. He came with his own gear, and then through the video, like he's doing stuff that probably any of us would do. I mean, there's a part where he like, oh, he uses the wire strippers, and then it goes over to the guy, and he's got his hands on his hips, like shaking his head because, of course, you don't strip wires at NASA. You got to use this little thermal thing to cut the insulation off with heat so that you don't nick the wires. Which we
Right.
all know that, right? You use wire strippers and you take a couple conductors off, and it doesn't matter for our kind of stuff. But if you're sending this thing to spin around the backside of the moon, you probably want to make sure everything is intact, right?
Yeah.
So it's a really cool like microcosm, I guess, of that time period, but absolutely still valid for most of it. I mean, like these aren't crazy concepts. They say, make sure that you're using a clamp so the thing don't move around. Make sure you're not overheating any kind of sensitive components. I mean, these are all still totally valid rules to live by.
Yeah, I love the production values too, and I think these movies used to cost them a lot of money.
Oh,
back
I'm sure.
In the day.
I'm sure.
First of all, it was shot on film, right? So just that alone, and then like done with voiceovers and stuff. They're not just like pointing a video camera at and phoning it in. This is like really serious production going on behind these, and that's kind of fun too. What I think is great about these is that NASA does this kind of public service part to show us all how what their standards are like, how their processes go. And I remember actually a few years back now, and I'm looking at it, it says it's from 2016. Hackaday wrote about it. Specifications you should read, the NASA workmanship standards. I actually read these when I first encountered them, which might have even been before then. They're fantastic. That's another one where it's just like, here is how to solder to NASA standards. And, you don't have to do all of it. And like you said, like, we don't really have to use those heat strippers. Although Al Williams shows up in the comments. Al loves those. And he's like, I think he even got first post in the comments saying,
Yes, I did notice.
saying big ups for the heat strippers because he loves his heat strippers. I've never tried them, so I shouldn't be talking. I nick wires for sure. I like the handheld ones. But anyway, the NASA workmanship standards are fantastic. One of the other things they have you do is leave a certain amount of the wire at the top so that you can see the fillet and how it forms with the, like between the wire and the board. The reason you have to leave it sticking up is not because they want to poke their hands on it or anything, but it's because that is useful for the quality control people later on to look at it and say, oh, this is a good solder joint, this is a bad solder joint. Because you can see how it, how the solder must have flowed and how it wicks into the wire and all that sort of stuff. And so some of what's interesting to me about the NASA standards is that a lot of it is about how to do the job right. And then a lot of it is how to do the job so that it's inspectably right.
Mm-hmm. Yeah, absolutely. Which is something that we all don't really have the luxury of anybody coming behind us to inspect it, right? But certainly anything that was leaving the planet, you could count on 4 or 5 people looking at it and having to sign off on it.
Yeah, but if you get into that mindset, maybe it'll help you kind of, look out for yourself as you're doing it. I don't know.
Who knows? Maybe we will come check around your work.
Yeah. Here we come.
The little elves that come out at night.
And if you really want to up your soldering games, I think I must have talked about this video series a couple shows ago because I still have it fresh in my mind. There is a series of how to solder videos made by Pace, and there's a 9-part series, and each one's about an hour long. This is another one of those, must be out of the 60s, really nice series of instructional movies. The first one is fantastic. You should absolutely watch it. It talks about time and temperature and things like this. It's a little bit, it gets a little bit deep into the weeds at times, but it's actually super well done. It's kind of a historically interesting because they talk about soldering wires to funny lugs and spade connectors and all sorts of things that we don't have anymore. But you can skip out to lesson 6 where they talk about component soldering, and maybe lesson 9 or something where they finally get into how to solder dip packages and other modern integrated circuits.
All right, well, this next one, I'm really glad Al Williams picked this up. We had kind of a debate behind the scenes about this, and I actually don't know where we left it, if we intended on writing it up or not, but it's called Just in Case You Want to Charge Your Neighbor's Tesla, which I think is a fantastic title. The idea here is that if not Pike found that there's a set signal, a 315 megahertz signal, that if you play over, I mean, in this case, it's a Hack RF or whatever kind of transmitting software-defined radio you have. If you play that, the Tesla will pop open its little rear battery charging door, and it's not like a rolling code. It's not specific to the vehicle. It doesn't seem to have any kind of authentication at all. You just play this signal. You don't even have to capture it, too. They put it up on GitHub if you just want to download it and open up, like Al says, your neighbor's Tesla. You just play it and the little door opens up. And, so right off the bat, you say, oh, wow, this is like an exploit. This is something that can be, detrimental. But I kind of don't really see it, because it's, my car's sitting outside now. Somebody could certainly go open my gas cap and actually take my fuel out with a hose. Unfortunately, the electrons don't seem to come out when I put the hose in the Tesla, right? So the idea that someone can open the, for lack of a better term, the fill door on these vehicles does not strike me as a big risk, because you can't do anything once it's open. It's just kind of like a novelty. I think the more interesting detail is that it's automated and the car is listening for a signal. But in my mind, and we said this kind of on the weekly chat we have, that to me says that Tesla is imagining a future where they're doing autonomous charging, and that some kind of a charger needs to tell the car, hey, open your thing, because this robotic arm is going to plug the other end in, I think if you imagine that future where some kind of charger needs to tell the car to open its door, I don't think you really can have any kind of authentication, or, it sort of needs to be as dumb as possible, because it all hinges on that door opening, no pun intended. It hinges on the door opening. Like, you can't charge the car if the door doesn't open. So, like, you don't want to complicate it with any kind of, let me, cross-reference this against the VIN or something. Like, just open the door. Open the door. Here comes the power.
Yeah, what's interesting about it is basically as simple as it could be, right? Like, it's 315 megahertz, which is a common commercial use band. Like, you can buy little on-off keyer transmitters for this for like 50 cents a buck on eBay.
Oh, yeah.
And it just sends out a fixed binary string at whatever, 2400 baud or something like it. Like, it's dead simple what's going on here. Like, this isn't a secret. They're not trying to make any attempt to keep you from doing this. And I really like your take that, if it's for an automatic charging station or something, because it would have to be the same for every car. You can't, like, first have this secret protocol where you exchange some handshake with the car and then you can open up the like, power plug door. Someone mentioned siphoning, gas from other people's cars, and it definitely gave me the chance to write in the comments a snarky comment about having tried it with the Tesla. And when I put my mouth to the cable, everything went black, and I woke up in the hospital. Further wild speculation, as long as we're here, 315 megahertz is standard for like remote controls in the States, but I think it's a reserved band here in Europe.
Oh.
And we use 433, like 432.9 for everything you'd use 315 for in the States. But it does make me wonder if Tesla's running this on 433 here in Europe, and if I should go snoop this out myself with an SDR and make waves.
And then why not just do 433 everywhere, too? It seems kind of weird that they would make the change. If you have to keep it that way for Europe, why did they do it different here? The SDR is way, way overkill. Like, you definitely don't need to spend the $300 on a Hack RF to do this. I like, you could definitely do this in like a little clicker form factor, like an 8-bit microcontroller and one of the little transmitters. So, I mean, that will be, if you are looking for a weekend project, if you can replicate this with a little handheld clicker, let us know and we'll make sure to put it on the site.
All right, my next hack is Nick Pool's best ways to make PCB breakaway tabs revealed. Nick works for Spark Fun and got told by his boss to figure out what's up with mouse bites. And rather than just say, I don't know, do what everybody else does, he placed a $400 PCB manufacturing order with all sorts of variations of hole sizes and hole spacings, and he got himself a fish scale, put these in the vise, and broke them to see what the breaking force was on all of these various mouse bite patterns. And it's kind of fun because the traditional recommendations is like 20-30, so 20 mil holes spaced 30 mils apart, or 20-50 if you need it to be really robust. And he likes, for a number of reasons, a lot smaller holes, so 15 mil holes spaced at 25 mils apart. And the SparkFun write-up of this is a really good read, but you should absolutely head off to his PDF report where he takes it one step further. And it's clear that Nick was really sciencing the mouse bites here, because he first starts off with kind of 3 different requirements for mouse bites. And if you don't know, if you get a bunch of PCBs made together, like all in a panel, you eventually have to separate them, right? And so you can break them apart. If you have lots of nice square lines, you can do V-scores or V-cuts where you just snap the whole thing. And those are pretty awesome. But if you have irregular shapes, you have to figure out a way to attach the little subboards to the bigger panel. And the most popular way by far is to use mouse bites, which are just kind of little tabs with a bunch of holes drilled through them. And his requirements for good mouse bites is that they have to stay together while the board's getting manufactured. So the mini boards have to stay together in the whole panel, but they also have to be able to come apart when the time comes. And they have to come apart with a small enough force so that you're not breaking the parts that have newly been assembled to this board. And they also have to kind of not suck. And by that, he means qualitatively, like no loose edges, sharpy, pokey edges. It doesn't want to rip off weird. And that part I thought was really interesting because I've always experienced mouse bite boards where, like, you have to sand it down if you're ever going to put the thing in your hand, right? It's fun that he's interested in that side of things as well. His final recommendations, other than just kind of more smaller holes spaced a little bit closer together, are also, the one that I thought was really clever is he makes sure that he has holes drilled in the corners where it would otherwise be milled out. And the idea there is to avoid those kind of little pokey fangs that you could otherwise get at the end of the mouse bites. And those of you who've, pulled enough boards apart, you know what I mean. He's got a solution for that problem.
I appreciate you saying that he scienced the mouse bites, because I was the one who edited this post, and at first when I saw it was posted in the science category, I was like, it must be a mistake. But then after I read it, I was like, no, this is like proper science. Like this is the real deal. This is scientific method. This is, gathering data and making a real comparison. It wasn't just, throwing stuff against the wall and see what sticks. We're lucky to have them. We're lucky to have people like this that we're doing this kind of, because I couldn't imagine. This is, I guess if it's your full-time job, right? Like he definitely took this one and ran with it. But I mean, it's not a surprise to see this coming from Nick. Like you said, he has done talks at SuperCon. I think what was his one, how to boggle the board house or something, I think was his last talk at 2019. And it's about like just this kind of stuff. How do you find the absolute limits of what these people are capable of? How do you just keep pushing until they break and then write a paper on it? So
it's important if you're doing like art badges or, trying to make 3D structures or circuits or whatever. Like he's really, pushing the edge of what you can do with PCB substrate. And so, yeah, naturally he cares about this stuff.
Yeah, absolutely. I mean, I would say, the average, Hackaday reader probably, if they're getting PCBs made, they're probably just, little square boards. And this is not something that you're going to have to worry about on your first or even second board. Like, this is definitely the advanced stuff. Or like you said, if you're trying to do some kind of artistic thing, or you need it to look exactly so. I mean, this is where you gotta find the edges of the envelope. You gotta weed out the ones who aren't up to the task. So it's fantastic information to have, and the fact that it's out there for everyone, of course, is really important. That this isn't paywalled behind some crazy thing. We can all just grab this and benefit from it. Is awesome. Well worth the $400.
Yeah, right? And he doesn't come up with one recommendation either. He does mention that you can, if you need, for whatever reason, the panels to be stronger or less strong, you can play with that. And he recommends just keeping your drill sizes all the same, but just increasing the spacing if you need it to be stronger. And it varies with how thick the board is and, all these other things. And he kind of, at least quantifies it in his tests. So you can see how you fall on these scales and say, I want it to, my board house is able to do lots and lots of smaller drill hits, which will end up with a nice clean edge. And I don't need the strength particularly. I want to do it this way. So you can kind of read along and see where you would make deviations from like his chosen kind of best, most average formula in the end too. So it's really just a super handy resource.
All right, well, this next project kind of speaks to me personally. I really like the water. I don't know, it's one of my things. I like being on the water, and we don't see enough water projects for whatever reason. This one, robotic boat rides high on PVC pipe pontoons, is maybe the answer to why we don't see them very often, is because you have to do a lot of custom work. I mean, there's not a lot of turnkey platforms if you want to make your own robotic boats like there is for, ground rovers and even flying stuff. Probably speaks to, the relative popularity of like RC cars and flying things versus RC boats, that there just aren't that many out there, and what's out there isn't really super useful for autonomous robotics and that kind of thing. In this case, Westgood had to come up with a custom design, stable, floating platform that you didn't have to have a research and development budget to build. And the solution he came up with, which I think is really elegant, is to take 4-inch PVC pipe that you can get from, the hardware store, 3D print end caps for the sides, seal them up, and then there's a little, I guess you'd call that like a little gangway sort of thing that connects them with the electronics box on top. So you have this floating platform. Some of the comments said, "Oh, it doesn't. Oh, I think it'd roll over." I don't know. Maybe they weren't looking deeply at all the pictures. I mean, the stance on this thing is super wide. Like, I think if this thing rolls over, you've got worse problems. Like. I mean, first of all, he's obviously operating it in like inland waters that aren't exactly getting too rough anyway. But I mean, this thing it's shaped like a pyramid basically. The base is super wide, and there's like this little tiny electronics box on top. Another one of the cool things I liked about this is that instead of having like exposed propellers and rudders and linkages and that kind of stuff, he's using 2 hobby jet drive units. And the rear 3D printed cap takes that into it. It's not just the front is just like a cap, it looks kind of like a torpedo, but the back is a cap that has a foot on the bottom, and that's where the jet drive sits. And that's really good for shallow water. You don't have to worry about smashing the prop on the ground. You can use differential thrust to control it, so you don't have to have any kind of rudder behind the thrust. You can just speed one side up, slow it down, let you spin around, so it's actually a lot more maneuverable than it would be like a traditional propulsion. There's a lot of cool details here, like the batteries are down low in the pontoons too, so like all the weight is as low as possible. This is not a one-off thing.
That's right.
This is a long-term project. At first it seems like you got the pontoons and then it's got this elevated electronics box, and you're kind of like, all right, cool, I guess it's high, to keep it out of the water or whatever. But then if you look deeper into it, his plan is actually to sling payloads under that elevated box. So like that's why it's so high off the water, because the idea is that you'll get a sonar module or whatever, like a water sampling thing, whatever you're trying to do with it. And there's little like hard points under the electronic box that you can mount it to. Oh, cool. So this is like the carrier for modular science packages, so I mean, he's really going all out with this. It's not just like a one-trick thing. I mean, you could even imagine if this was something that became popular, you could have a whole collection of like community developed payloads that could, mount into this thing, because there is a demand for like, citizen science kind of purposes to have a stable autonomous water platform that doesn't exactly exist yet. Another nice detail is that apparently he's a mobile app developer by trade. So the control for this one is done on an iPad, and I mean it looks phenomenal. It's very, very slick. It's clearly this comes from somebody who does this for their day job, right? Like mine certainly wouldn't look like this. I mean, he's got a little like. There's a part really like it's got a pitch and roll indicator, and it's got like this little tiny 3D model of the boat that actually like rolls and pitches with the degrees under it. It's just little touches like that where it's just phenomenal.
The other thing that who wrote this up?
That would be
Nardi.
me. That would be me, the nerd who likes the boat robots.
Oh, dude, I'm with you. But I totally agree with you that boats are like the final frontier, and I think it's a lot harder than doing it with a drone or with an airplane because there's nothing to run into up in the sky. You get it up above the trees, below the airplanes, and like there's just nothing to hit. Whereas if you're a boat on the water, there's like seagrass and there's ducks and there's canoes and there's tree roots sticking up out of the pond. I mean, who the heck knows, right? Like, it's a much more challenging problem, I think, in a bunch of ways. So it's kind of cool to see people working on it.
And I should say, we don't have a whole lot of information about this project yet. This kind of came from a couple Reddit threads, and, there's a bunch of pictures. I mean, he's done an excellent job documenting that, but I don't think there's any details on the software side of it. We can't control how people want to document their projects, but I do hope that he goes the extra mile and, puts it on GitHub or something, whatever he's willing to share, because I think there is definitely, there are other people who would like to go down a similar path. And it's just, there aren't a lot of great examples to go with that are affordable and practical. It's very impressive for that alone. This is very accessible for anybody, even just the hobbyists. You don't have to be sitting on a grant or anything to put this out in the local lake. You could definitely do this on your own and, break some new ground or waves, as the case may be.
All right, Jörg Flug came to us this week with a mind-blowing graphics library for the ATTiny85. He actually did such a good job kind of demonstrating the things that his little graphics library could do that a lot of people in the comments especially mistook this for like a demo scene project. Each of his little examples is like a demo, but it's a demo of how his code library works. And that's what's really cool about this to me, is that this is more than just a, hey, here's some really cool graphics tricks I can pull off. This is a graphics library that you could use if you have a project that's got an ATTiny85, one of those small I2C OLED screens. This one is the SSD 1306. If you are in that camp, or if you're thinking of developing one after you see this post, go check out his ATTiny Stream GFX API project over on GitHub. It's really awesome. It implements kind of all of the graphics primitives you'd like to see for an ATTiny85. It's got layers, it's got sprites, it's got 2 separate text consoles with different font sizes and stuff. It can zoom, it can scroll, it can blend these screens together and output them in a nice dithered black and white version to this OLED screen at what looks like a really fast frame rate. Like if you watch his videos going on, you would be shocked that it's an ATTiny85 doing this. I wrote this in the write-up. Some of these demos are a little bit underwhelming unless you realize what they're doing. Like he has a picture of an alien and then it gets static that fades in and out in front of it. It's doing this live. The static is actually just random numbers that it's a random number generator static currently that he's running in one of these layers and blending across this image of the alien, and then it has a "We Come in Peace" text that comes off of it. This is showing off the ATTiny adding together these different notionally grayscale images and then dithering them out to an OLED full motion in real time. Again, did I mention this is an ATTiny85? This thing has 8K of flash memory, which really made me laugh because M in the comments asks the fundamental question, how many resources are left over? Someone else, wise guy, Thomas, answers 1. Because it's true, this must consume a lot of the resources. Although if you look through the code base, he's got a lot of basically defined statements that let you take out functionality you're not going to use, and etc. The other thing that's really cool about this, it's all written in kind of raw C++ to get this kind of performance and stuff. But Jorg is also working on integrating it with Arduino code. So it's not 100% there yet. This is not an Arduino graphics library, but he's taking steps to make it useful for that sort of thing too. So if that's where your interests lie and you like the comfortable, warm Arduino environment, this still would be something you could make use of.
And I think, if he does get that compatible, with the Arduino environment, that's really going to really open up a lot of possibilities for a lot of people. It'd be very exciting to see what the community can do with this. Looking at it, it almost, like you said, it almost looks fake. Like, I got to be honest. You see this little 8-pin chip. There's nothing else. It's just the chip and the screen and jumper wires, and it's almost like, where's the thing?
3 I2C wires.
Yeah, like there's got to be something. I'm like, is the back of the breadboard hooked up to something else controlling it? But no, this is the real deal. It's very, very, very impressive. I think being confused for a demo scene thing is probably the highest compliment your graphics library can get. Right, like that's the high watermark.
Yeah.
It's so cool to look at it. You want to just grab a chip, like right now. Like, where's the screen? I must have one of these screens, right? Like, this is the definition of a junk box build, because like you probably have this stuff.
I would have done it,
already.
but I don't have the screen anywhere.
Oh, you don't have the screen?
Yeah.
Oh, I have like 4 of these
I
screens.
actually looked to see if I have one of these screens.
They're so cheap. Like, that's the cool thing. Like this is the cheapest stuff. These little displays and the chip, and that's all you need. I mean, it's even if you just want to watch the thing roll through it on your own to prove that there's no trickery involved. There's no man behind the curtain or anything.
And before we leave, on the demo scene tip, Antiemes came in and left a link to Gravity Waves, which was entered in a demo scene contest for Arduinos, and it uses the same display. You should go check that out. It's all written in kind of straight up Arduino, but it's actually a really accessible code. It's up on GitHub, link in the show notes. That's a really nice similar demo, not aimed at being a library necessarily, but it's readable code and you can work along with that. So if you're interested in this kind of low-level, primitive, microcontroller-driven graphics stuff, you should check that one out too.
This next one comes our way from Electro Noobs, and it's coin acceptors are higher tech than you think. The idea here is that Electro Noobs, he got his hands on a commercial off-the-shelf little coin acceptor that you might see like in an arcade machine or a vending machine. And he wanted to tear it apart and show how it works. So on one level, this is a teardown because it's a consumer thing. They takes apart and he really goes all over it. But what I think makes this special is that each kind of subsystem in the coin acceptor, whether it's checking the size of the coin or how fast it rolls down and all that stuff, he actually sort of breaks out and recreates in a very accessible DIY kind of way. So, it's not just, okay, here's a commercial thing, here's how it works, and keep it moving. He really does show you how every function can be replicated, with an Arduino and a couple little sensors. So it's very educational, and if you had some kind of an application where, you want to accept some little tokens for some gadget at the hackerspace or something, you could replicate these things. I wouldn't gamble any real money with it working, but be enough just to play around and for fun. With the way he replicates it, but it's really cool to see just him take that deep dive, and it's a nice approach to doing a teardown. I don't know that I've ever really seen it kind of presented this way, and I think it's sort of like a high watermark for this is how this thing you probably interact with all the time. This is how it works, and this is how you can learn more about it.
I have to say, I kind of underestimated the coin acceptor before watching this video, and the things that I thought were really neat are all kind of doing a lot with as little as you can. It's got 2 brake beam sensors, and the coin rolls down a ramp, so you kind of know what the incline is, and you can use the fact that there's 2 brake beam sensors to figure out how fast the coin is going. And then you can read off of either one of them how wide the coin is, because you kind of know how fast it's going by the pair of sensors, but then you also know how long it takes to roll through any one of those given beams. And that's just like it's a clever, super easy design, right? It's 2 LEDs and 2 photo transistors and then a bunch of logic. But from that, you get some information about how much mass the coin has. You get a direct measurement of its diameter. Like it's a lot to get if you're trying to, sort out coins, which differ in all these different ways. And then he goes and he looks at the inductive sensor, which figures out how much metal there is in there and what it's made of by kind of pulsing a field across it. So it's really cool. And I totally agree with you. Like, the star of the show is him then taking some plexiglass and making his own inductive sensor to see what he can learn from it. That's really cool.
And I like, too, where he mentions, you think maybe you have to have a different firmware for different regions and that kind of stuff, because obviously local currency is going to be different. But he talked about how the acceptor actually has a learning mode, too, where you can just say, hey, pay attention. And you put the same coin through a few times, and it records all its parameters, which lets you not only do different local currencies, but even just an arcade token, something that's not like a real coin. You could just have a bucket of them and just throw a few through. It learns it, and you don't have to redesign it for different coins and that kind of thing. I did think it was interesting at the end. You can recreate all this stuff, but at the end of the day, apparently the coin acceptor only costs $20. So it's
dude,
you can recreate it, and here's how to do it, but it's $20. It's not exactly breaking the bank. It is kind of amazing to think all that can be built into it for $20. But of course, you're talking about something that's been, the economies of scale have been working on it for 80 years, I guess. I mean, how long have you been, accepting coins in little machines like this? Are you going to build one yourself? You could, you could, but you could probably just grab it for $20 and enjoy the fruits of all the labor that's come before it.
My first quick hack this week comes from Nikodem Bartnik. He runs, among other things, a YouTube channel where he's been making his own DIY CNC machine. This is an addition to that machine. Skip the shipping, print your own cable chains. And this is yet another DIY cable chain design. And I love his story here. He finds a couple models. None of them work quite right. He's like, I'll just do it myself and make it parametric. If you feel so inclined, you can check out his models, or you could just do it yourself, make it parametric. Next up, another maker stress testing an Arduino's EEPROM. This is a fun one because if you look at the ATTiny chips, it says the EEPROM's good for 10,000 writes, and you might be wondering, am I going to break this thing? The answer is probably not. He did an experiment where he wrote ones and then zeros and then ones and zeros to the EEPROM. And depending on which run he did, he got between 2 and 5 million writes out of the thing. Last up, Lingib, Hall Effect Module knows where your motor is. This title's a little misleading. This is actually an MLX 90393 3-axis magnetometer. And therein lies the hack. This is sensing rotation of a motor using something that's normally meant to sense its position in the Earth's magnetic field, You put a magnet, of course, on the end of the motor and read it that way. This isn't one of those nice high-resolution magnetic rotational sensors. This is indeed a magnetometer abused. The advantage of doing it with the magnetometer directly is it gives you the analog output of field strength in the X, Y, and Z directions, maybe letting you calibrate out some errors or just play around with how these things work.
My first hack comes from Hack Make Mod, and this one's astrophotography on the Game Boy camera. At the core, this isn't really so different than a lot of the other Game Boy camera mods we've seen. I think someone must have recently catted up the Game Boy camera, so now everybody's spinning off their own 3D printable designs for lens adapters and that kind of thing. But it is, as far as I know, the first one who's put a big lens on the Game Boy camera and pointed it skywards. Sensor is pretty limited, but with the right lenses, you can get some fairly impressive pictures of the moon. And as an added bonus, you can also swap it out for a macro lens and get some really nice close-up shots. Next up is SDR Listens In on Your Tires from Ross. This one is a quick hack in all forms of the word. I mean, you just have to download RTL 433 software and use your RTL SDR dongle, and you can listen in on the TPMS sensors that will almost certainly be in your vehicle's tires if it was made after 07 or somewhere around there. It's a really cool example of the power of cheap hardware and open source software. And on a personal note, I myself recently had the little light go on my dashboard because some of the batteries had died in the sensors, and I had to go and get it checked out. And if I had seen this article a couple weeks ago, I could have done it for myself right in the driveway. And last up is Wordle comes to the Nokia N-Gage thanks to the new SDK. I can't imagine there's a whole lot of N-Gage fans in the audience, or in any audience for that matter. It was a laughably poorly designed handheld that tried to combine a cell phone with gaming and didn't do either very well. But Michael Fitzmayer wants to bring it back, and he has pretty much spearheaded this effort to make a modern SDK for the system, so you don't have to use whatever antiquated software Nokia must have shipped out in the early 2000s. Little games like this are kind of a way that he's showing where he's at and what's possible. I'm not saying I'm going to buy an N-Gage, but I am pretty curious about what modern kind of software could be developed for this platform, which you can literally get for a song on the secondhand market right now.
All right, it's time for our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And this week, I've picked Dan Maloney's Mothballing Rosalind, How to Put a Space Mission in Storage. This is about was this ExoMars rover that has since been named Rosalind Franklin? It's a European Space Agency rover that was set to head off to the Red Planet and drive around and do some science. It was scheduled to be launched on a Russian rocket, and then due to the war in the Ukraine, that cooperation between the ESA and Russia has fallen aside, and it looks like they're not going to make their launch window this fall. So the question that Dan's article gets pretty deep into is, what do you do with your space rover that's meant to go to Mars if it's going to have to sit around for at least 2 years and maybe 4 years? And the answer is kind of surprisingly pedestrian. Like, a lot of the things he mentions are things like lubricants. You have to make sure that the oil doesn't go bad and the grease doesn't end up horrible. And I was like, yeah, okay, that's kind of lame. But then he brings up the example of Galileo, which, because it was delayed by the Challenger disaster, had its grease go bad and actually had trouble deploying its high-gain antenna way out in space because it had been sitting around for a while. So that's one of the concerns. One of the other things that can go wrong are kind of the pyrotechnics, and a lot of parts on rockets and on spaceships and space robots detach from each other by using small explosives to blow things apart. And there's a concern, of course, that these will go bad and fail to deploy when they need to. So, yeah, I got to keep them in a cool, dry place, as he points it out. The thing that probably isn't going to go wrong with the Rosalind Franklin is it doesn't use radioactive thermoelectric generators, RTGs, for its power supply. It uses solar. It does use radioactive devices to help maintain its operating temperature. So it's got like little plutonium heaters all around. And of course, they're going to decay a little bit, but I don't know how long that's going to be. If the mission goes off in 2 years, what's the half-life of plutonium? 80-something years, 90 years? I don't think that's too much of a worry for like this kind of secondary role as a heater. But if this was the main power supply for the thing, you might be worried that it's going to lose some of its radioactive juice by the time just sitting around in dry dock until 2 years from now or 4 years from now or who knows, 6 years from now.
Yeah, well, right. Who knows? I mean, that's the big question, because it's not like this was delayed on account of bad weather. It's delayed on account of political upheaval that we haven't seen in a very long time and still has no end game, right? So, like, we don't know when or how this is going to launch. And, you know, of course, compared to what's going on in Ukraine, that's a minor concern, right? Like, Mars robots are not the biggest worry right now. So you can see why it would just get kind of packed away, you know, to be dealt with on another day. It kind of brings up an interesting point. I don't know that Dan actually touched on it in this, is that you might say, oh, hey, just put it on another rocket, right? Like just stick it on another rocket, shoot it up in space. But, you know, it's a lot more complicated than that. You know, it's not exactly like Legos, right? Where you just take the thing off the top and put it on another one. You know, it was designed for its specific launch vehicle and everything from, you know, the physical mounts to what kind of vibration testing it would have went through. It would be all specifically for the rocket that was going to carry it. So, you know, especially on something that's this important and this delicate. I mean, if it was a, you know, little communication satellite or something, they might say, you know, whatever, it's not that big a deal. But I mean, this has been tested and retested, and everything is planned to the most minute detail. So you can't just say, okay, you know, call SpaceX and be like, I need a ride. You know, it's not that easy.
Yeah.
You know, it kind of speaks to, you know, maybe we should try in the future, you know, to make it easier to switch vehicles like that. There would be pretty clear benefits where if you could just take a payload from one vehicle and put it on another, but we're pretty far away from that. Although, you know, if commercial continues to be as big as it is, and you know, you imagine a future where most launches are, well, I mean, we're probably there now, actually. Most launches are already going to be commercial, but you know, you'd start developing these things with a more, you know, launcher agnostic approach, right? Like you would say, okay, we could ride on these 3 rockets, you know, so you don't get stuck in these kind of situations. Especially going to Mars, because the window only opens every 2 years, right? So, you know, there's not a lot of time to figure this out. You know, it either goes now or it just doesn't. You know, you can't, you know, you can't say, well, we'll push it back 2 months, because that 2 months, you know, you missed it. You missed your window. So that might be something that becomes more common going forward, is that, you know, that might be the biggest takeaway, is that, you know, this is the unfortunate reality. When you only got one ride to space, you know, things can get in the way. And I don't want to be negative, but I mean, it's possible this thing may never fly. You know, who knows what's going to happen? You know, they might find they take it out of storage after 2 years, and they're like, oh, you know what? That ain't gonna work. You know, something could have happened to it, or you know, the nature of the mission has changed and they want to do something different. You know, who knows?
Dan opens the piece with something that surprised me, actually. He said there's this Mars curse, and that about half of the spacecraft have ended up failed in one way or another that we've sent there. And when I think about Mars and Mars exploration, I've got all of these stellar successes in my mind, right? Like all of the NASA rovers that have had a 3-month program and it went on for 15 years or something, right? Like there are also at the same time all these stellar successes, and it kind of makes you forget, I guess, just how hard that sort of thing is, and also how long the planning horizons must be here. The long planning horizons, I think, speaks a little bit to your point about whether these could be designed in a more rocket launch agnostic way. 15 years ago, 20 years ago, when they were starting doing the planning for this project, there was no competition in space. This wasn't even a thought. I do think that's a great insight, and that we'll be seeing stuff like that further in the future. Basically, payloads that are designed to go up with whoever will take them, and that would offer a very useful extra amount of flexibility.
All right, my can't miss article this week is a review for the Visi Linux-powered AI camera. This is from Donald Papp, and I got to say, when I first saw this, I say, all right, it's a camera. What is there to say about it? But I definitely misjudged it because, you look into it closer and, Donald at one point he describes it as like, basically this is like a Raspberry Pi case that happens to be a camera because there's not like a Raspberry Pi compute module in here, which is what I thought. I thought, okay, fine, there's a compute module in there. It's a custom board. No, it is literally a full-scale Raspberry Pi. It's got the Ethernet, it's got the USB, everything's exposed right out the back, which incidentally, you're not putting this outside. there is like an overcase that if you have to put it outside, but like by default on the back, there's everything you'd expect is fully exposed. It's just kind of like a case that sits on top, and it adds a little board that plugs into the GPIO that handles, the power, runs the fans, and has like expansion, that kind of deal. And the camera module is not the same as the Pi high quality module, but it's I think the same sensor, he says in there. It's a similar kind of setup, but with lenses and all that. And it all just plugs right on top of your regular Pi. And, Donald even says, like, the software is set up so if you plug a keyboard and a monitor into the back of this camera, there's a desktop. I mean, this is about as hacker-friendly as a product could possibly be. Like, there is nothing that keeps you from doing whatever it is you want with this thing. Part of the review is Donald goes into some of the things you could do with this because, you have all this software at your fingertips. You can install whatever you want. The Pi 4 has a pretty decent punch. So, doing computer vision stuff isn't really a problem. And you have this expansion header on the side that's, tied into the GPIO. So you could, open the gate when a certain person walks up, or, you can turn the lights on. There's so much stuff that you can do. You can hook it up to sensor readings and maybe, overlay the temperature and stuff on the video feed, all kinds of cool stuff. It is like the epitome of like a hackable camera. And one of the really cool things that he touches on here is that they make it as accessible as possible. And right from the web interface, you can hook up a keyboard and mouse if that's your style, and you can do whatever your usual software development, workflow is. But you can also just go right through the web interface, and it'll pop open an editor, right? Like in a new tab, and you can edit the Python code for the built-in functions or add new ones. And I mean, it's a really slick design, very accessible, no matter what your experience level is. And he kind of ends it with saying, like, this is the way, like this is the way things should be, and obviously there's a lot of the average consumer doesn't need all this kind of stuff. This is definitely made with folks like us in mind, right? But like, this is the way you do it. Like, you don't have to lock anybody into like the proprietary hardware. You can use an off-the-shelf, single board computer. You can, make sure that you can do things the way you want to do it, or their official way. Like, there's no arbitrary walls or things in there in place, and it's just a really cool open platform. Although I don't know, like, letter of the law how open it is, I should say. they might have, I don't know if it's open hardware and that kind of thing. But definitely it's very accessible, and that's really cool, and that's what we like to see. And that's what we like to support too. So it's cool that he was able to bring this to light. I hadn't heard of it before this, so it certainly got my interest.
I saw one program they wrote called Motion Scope that looks really interesting. It does tracking of moving objects, and because it's video, like if you have a bouncing ball, it can tell you where it is at every frame and track its center using OpenCV, and then tell you how fast it's going. And like for, I don't know, a high school physics experiment or something, this would be phenomenally useful. And for a high school physics experiment, you're not going to design and build this whole stack yourself. So having something off the shelf like this that has this kind of easy functionality built in is super, super useful. What Arduino did right and what it looks like these guys are doing right is they make the hard stuff easy, but then they don't box you in. Like you said, they leave everything open. It's, you can write your own Python code for it. In the end of the day, it's a Raspberry Pi running this stuff. It's all completely modifiable by the end user if you want to, but you don't have to if you don't want to. And that kind of, again, I don't know anything about this particular camera except from reading Donald's write-up of it, but that sort of development strategy seems to be both hacker-friendly and kind of non-hacker friendly or proto-hacker friendly. People who are new to the game will also find this useful and maybe use it as an entry point to get them in deeper and stuff. I know the Pixie, which was their previous AI cameras, brought a lot of people into doing computer vision projects who wouldn't have done it before. And so, yeah, that's all good, right?
I think there's certainly also a market for networked cameras that aren't beholden to some company or some cloud service or something like that, because, the options out there kind of suck, to be honest with you. We were looking for some cameras. I want to put a camera in the baby's room, and sure, you can go out and grab one of these cameras, these little blink cams and stuff. It's $20. Oh wow, they're all cheap. But then you realize, like, okay, well, now there's a monthly thing, and by the way, we're going to send you. We're going to send your video to get processed somewhere, and sign away your life here at the dotted line for your cheap camera. Like if it's cheap, there's a reason it's cheap, right? So, I mean, something that you could, for the privacy-minded people, a camera where you could know that the only place it's going is your client side, and there's not phoning home anywhere. There's a big value in that. I mean,
doing it yourself like that is so easy, man. We had a couple years ago, this is bizarre, but we had a hedgehog that moved into our grill outside. It just
as they do, right?
Took up a home, and so we built a hedgehog house for it to hope to convince it to move out of the grill. And then after years of neglect, there was a hedgehog that moved into this thing, and we're like, oh, this is so cool. So we took a Raspberry Pi. I actually bought one of those no IR filter cameras and put it out there, and we run that. And did I weatherproof it appropriately? No. Has it lasted outside for 2.5 years? Yes, it's actually no problem. I mean, I built a little kind of wooden, almost birdhouse for it and kind of put it in there, but it's definitely not professionally done. But the thing has worked entirely well for very cheap. And if you wanted a front door cam, you should just get a Pi Zero and one of those little $5 cheap Chinese knockoff camera modules and just be done with it, dude. Don't spend $20 on some dumb project that locks you into their software thing. But
there are people who would like a little something more turnkey than that. But you're not wrong. The average Hackaday person would be able to put their own thing together. But still a very cool platform. It definitely kind of got me interested. And I guess that's what a good review should do, right? Explain why it's worth your time and kind of open your mind to some new stuff.
That about wraps it up for this week's Hackaday podcast. If you'd like to get in touch with us, you can email us, editor@hackaday.com. As always, you'll find links in the show notes, hackaday.com/podcast. If you see anything cool or you do anything cool, send us a tip, tips@hackaday.com. And until next week,
keep on hacking.
I'm Elliot Williams, manager. Oh, what am I? Good Lord. ATTiny. Nope.
Here, in a few seconds, the work of many men and women will meet the supreme test.
All right.
One more time.
And oh yes, he's a ham radio operator.
You gotta make that like a shirt or a sticker or something. Parametric all the things.